Okay, so welcome to our day 3 of our data analysis with R. So a recap of what we treated yesterday. Yesterday we talked about the various data types in R and also various data structures in R. And though we started with some of the data structures, so we're going to be completing the data structures which we have in R. So we talked about the data types. We talked about numeric data types, which are number with the decimal value. We also talked about integer. And we talked about, so most of the time you can also assign an integer value or say a numeric to a numeric data type. And also talk about character. We also talked about Boolean value. We can just say logical value. The data types, we talked about vectors. We also talk about lists. Use vectors in assigning multiple values to a single variable. But out of you, these values are having different data types. This is where you now use a list. So we also talked about a list, and we talk about a matrix when you're having what 2 dimensions. So a matrix is has a two-dimensional data structure. Okay. So the matrix is a 2-dimensional data structure that into a 2-dimension, which is what rows and columns. And so talk about I can index on this data structure. That is your vector, your list, and your matrix. How can you get values from this particular data structure? So the next we're going to be talking about now is called an array, though it is not mostly used in R, but we'll still talk about it. So the array, unlike the matrix, which is 2-dimension, the array is 3-dimension. So in an array, we have a row, we have a column, then we also have what there's now broken down. It's like having what various matrices. So you can see something like this. Now this is an array. So you can see that we have matrix 1, matrix 2, and we have matrix 3. Then each of these matrices are having the same dimension, whereas this number of rows and also the number of columns. So now I want to create now a array. First of all, I'm going to create a vector of 30 elements. So which is what 1 to 30. So now you see when I'm to call this particular vector now, you can see I'm having what? I'm having 30 elements. Good. So now if I want to now create the array now, I'm going to be using the array function. So when I use the array function, so Mr. Oladimeji, thank you for joining.
Thank you, sir.
Okay, so let me just give a recap of what I'm talking about. So,
No, I got that.
Okay,
I've been here.
Okay, then. Okay, that's good. That's good. Okay. So now if you now want to create an array, use the array function. So I expect you after the class, you check more on the documentation. Since you can now check the documentation of functions. So you can also see other arguments based on the array function. So now I'm going to be giving my vector first into the array that will now be giving my dimension. So first of all, my dimension has to be what? The first is the option is the number of rows. Then the what number of columns. Then we now have the what number of what matrices. So each matrix is going to be having the same number of rows and the same number of columns. So that is why you see we created what 30 elements in this place. And now I'm now going to be using the array function to create our array. So when I run this particular code, now you can see I'm going to be having, if I'm to call an array. See now I'm having, let me just minimize this. So you can see my array now. You can now see that what in each what group, you can just call this a group. Group 1, we're having matrix 1, which is also having the same dimension as this particular one, and also what this particular one. So that's why array is called what 3-dimension. Most of the times you hardly come across array in R, but it's just a good thing to have a knowledge of how array works. So what if you now want to get the dimension of an array? I'm just going to use dimension function, and the array you just created. So you can see our array now. This is the row 5. This is the number of columns 2, and also the what number of groups or number of matrices, which is what 3. So we have row, column, and grouping. So that's how you also check for the dimension of an array. So that is just about this array data structure. The difference between the array data structure and the matrix data structure is that the matrix is 2-dimensional, just a row and a column. One array in an array you can have what various matrices. So it is 3-dimensional. We have the row, the column, and each matrix should be of the same dimension in an array. So now the last and the most important data structure is the data frame. So this is where you'll be dealing with what data, because most data are usually what, anytime you create a variable that is a data, is usually created as a data frame. So one unique thing as a data frame that in a data frame, we're going to be having what rows and columns. So the rows is likely to be your observations, while the columns is your variables. So for example, now you're analyzing sales data now. So each row now is the transaction that was made on a particular day. Or can say just the transaction that was made. So 2 transactions can be made in a day. So you can have transaction 1 in one row, transaction 2 in one row, and they can be carrying the same date. Then under each column now, you can now see, okay, the date a transaction was made. You can also see the payment that was made for that particular transaction, or maybe the client that bought that particular item, and also the items that was sold. So these are information which can be seen in each column. So in a data frame, we have various data types. One column now can be a date. Another column can be a character, for example, product name. Another column can be numeric, that is the price. So each column is of various data types, but within a column, all the values in that row, all the values in that particular column must be of the same data type. What I'm trying to say now is that there's actually some default data sets in R. So let me just give this particular one empty cars. So empty cars is one of R's default data sets. So let me use the view function so that we'll view it where empty cars. So you can see it's going to open up in a new tab. So this now you can see now is a data of various automobiles. So under you can see the properties. You can see now each row is a particular car model. Then each column you can see is the properties of this particular car, like MPG, CYL, and DSP. So as an exercise, you can check the documentation of empty cars. So just use the question mark and you know more about the data set. So now you can now see we have various properties. So now I would actually want to use a much better example. This is containing, let me use that of the iris. I want to have these are a good example now. So you can see this is the iris data set also. So a default data set in R. You can access it just by calling what the iris is already stored for you in R. So anytime you want to practice, these are data sets which you can use for practicing. So you call iris, you can actually use just call the iris. You are going to be having the results. So if you want it to appear just like you see it in an Excel sheet, use the view function. Okay, now, so this is our sepal.length. This is iris. So we have details of various flowers like sepal length, sepal width, petal length, and petal width. Then we also have species of each particular flower. So these are flower recordings. Now, if you look at it now, we have various columns, and these columns are of different data types. Though these four now have the same data type, which is numeric. But you see that of species is what? Of character. So now, what's one unique thing with a data frame? Data frame can have columns of different data types, but under each column, everything must be of the same data type. You cannot be having setosa and come and be having 0.2 in this place, or be having 0.5, and you'll be having true or false. It's not possible. All the values inside this particular column must be of the same data type. If you're having characters, everything must be characters. If you're having numeric, everything must be numeric. So this is one thing about a data frame. So the columns are of different data types, but within a column, it must be of the same data type. So it's one of the most important data frame, and that's one of the data frames which you'll be working with a lot in R. So most of the times, though, you can create your own data frame in R. Most of the times, you're just going to be importing your data frame because maybe the file is already created in Excel or maybe another spreadsheet. Your work is just to import it, but you can also create a data frame in R. So now, this is a sample of a data frame that was created now. You are going to be using the data.frame function. So the data.frame function allows you to create a data frame. So when you know how to create this data frame, what this function is now going to be taking is going to be taking vectors. Can you see why I now say each column must have the same data type? Because it's vectors are going to be given. Under name now, imagine I'm now having 9 in this place. There's no how R is going to create for me a numeric value and other values inside this particular vector are characters. So it has to cohort it back to a word string. So that is why we'll be going to be giving vectors. So now, first of all, now I gave a vector of names. You can see it now. And then I gave a vector of age, which you are seeing here. Then I also give a vector of their marital status. So is it true or false? So true means that a person, the individual, is actually married, while false means that the individual is not actually married. Then we now create this particular short data frame. So when I run it now, and I run workers, so you can see it. So this is why important is because I'm using an R markdown file. That's why my output is showing like this. So if I'm to call it in this place, workers, so you see what I'm having now. So this is just a short data frame. I can even use the view function and on my workers. So I usually like using the view function. It allows you to see your data frame clearly. So you can see this short data frame I've already created now. So if you now want, if you now want to add, let me ask a quick question. What if I now want to add the names? So how am I going to go about it?
If you want to do what?
I want to add more names.
So how am I
going to go? Yes, how am I going to go about it?
You can use the combine the R bind function.
Yeah, so I already have that for names now. I already have the details. I just want to add more names under it. So I just want to have like, let me see it. I want to have like 2 more rows or 3 more rows. So how would I go about it?
That's R bind.
Okay. So let me just, yeah, that's a good try. That's a good try. Okay, currently now, if you look at it now, we have names. So we have already created this data frame now, which we have here. But we want to add what more names. So what you just have to do is just go to our name vector and add what more names to it. So I can just add Mary here, and I'll add what roots to this place. So you can see it. This is how I can add what more names. But what if I now run it like this? Because I already added more names now. What if I now run it now? So you can see it is returning an error. So why is this returning an error?
Because the number of columns, the number of data in each columns must also be the same.
Exactly. So we need to adjust that of the age too also. We need to give them their age. Okay, give them their age. Then also come here. And so one thing also you should note, you can also write the true as what, just only T, and write the false as F. So it's still going to, they are both the same thing. So when I now go back now, if you also want to go to your previous code in the console, use your upper arrow. Can you see it? I'll be seeing all the codes I've already run all through. Can you see all of them? You can see all of them. All the codes have been running. All this was all from yesterday's class. So you use your upper arrow to access it. So now I want to go back to that view workers. I'm just going to be using my upper arrow to go till I come across view workers. So you can see I've already reached there and now enter. So now you can now see that I've already added more rows to my data frame. So this is how you can add more rows to your data frame. You just increase the elements. You just add the elements into your combine function for each particular variable. But what if I now want to add more columns to my data frame? How do I do that? So this is where I'm now going to add another vector also. I don't know if that's clear. I can just put children, or let me just put number of children, number of child or children. So let me just put it like this. Now say C. So they are now going to say 2, 3, 4, 5, 1, 6. I think there's it. Okay. So now I'm adding a new column. So for me to add a new column, I need to add a new vector of that particular variable. So when I now run this now, and I use my view workers, so you can see it now. I already added a new column. So I don't know if you people are getting the point now. For you to add a new row, you just come to your variables and just input the new values you'll be giving. But when you're adding a new row, it means you also be adding for other variables too also, so that it's going to be a match. Else you are going to be getting an error. But for you to add a new column, you add a new variable. So adding a new row, you add values to your variable. While adding a new column, you create a new variable. So that's just the difference inside the data frame. So you can see, so the data frame has other arguments which you can also explore. So just try and check the documentation. I want you to get used to checking with the documentation. It allows you to know more about the functions. It's a very good help. So when you are getting used to checking the documentation, you're able to know more about functions, and also there are examples to inside that particular function documentation, which you can also learn from. So now if you check documentation of data frame, you also see other arguments which you can use to further tune your function. But this is how you can just create a data frame in R. But most of the time you hardly even use this, because most of the data sets you'll be working with, you are going to be importing them. So these are already Excel or CSV files which you are going to be importing and work with it inside R. So I don't know if that's clear.
It's
okay,
clear.
so now, so now you can get a summary of your data now. So let's say summary of workers. This is another function that allows you to just summarize your data sets for you. So what summary actually does is that it summarizes your data frame for you. Where in a column where you are having character values, you're just going to get only the length of that particular column, class, and mode. So you are not going to get much analysis in a column which is what character. But for a column that is numeric, this is where I'm not going to be getting statistics like the minimum value. You can see the minimum age is 20. The first quartile, the median, the mean, the third quartile, and the maximum. So the first quartile is actually the values that are above 25% of the data set. Then the median is the 50th quartile. So any age now that is above 34, now we say it falls in the median class. And we have also the mean. Then we have the third quartile. This is 75% of our data set. So any value that falls above 43 now, we see it falls in the 75% class, or we say it falls in the upper quartile, which is the third quartile. So these are just basic statistics. Which one can use to what? Explore it there. You can see that married is a logical variable. So you can see we're having mode, logical, false, theory, the number of false, also they have the number of true. So more time when you use the summary function, I'm really interested in numeric value because that's where you get useful information. Most of this information are not actually something that is going to be, you are going to be needing or something that is going to be contributing to your analysis. But when it is for a numeric variable now, you can now know that, okay, I know my minimum value to be 20, my maximum value to be 45. I also know my mean to be 32.6. So these are results which you can actually make insights from and can also explain inside your report. So the summary function allows you to check the description of your data frame. Any data set you are working with, the summary function is going to summarize it for you. So now what if I now want to access the items in a data frame? Now currently in my workers, I tell that we also always use the square bracket to access items of data structures. Always use the square brackets. So now if I access index number of 2, I'm going to be having what? My column of H. Just similar to what you have in a matrix. Just treat it like that. If I also access workers 3, you see I'm going to be having what? Married. You can see my marital status. So this is what is going to happen anytime you use your square brackets. But we also have the use of what? Double square brackets. I also explained this. So anytime you use your double square brackets like this, you have a vector. So this is the difference. When you use a single square bracket, you have what? You're just going to get your column for you. But when you use a double square bracket, your column is going to be what? You are going to get the output of your column as a vector. So you can see the difference between workers 2 in double square bracket and workers 2 in single, okay, workers. So you can see the difference between the single square brackets now, and you can see what? The double square brackets. If you're actually interested in your column, you want the output to be the way your column is, you're going to be using the single square brackets. But if you want to you are only interested in the vectors of that particular data frame, you're going to be using the double square brackets. They also have another one, which most of the time is what is usually used in data frames. We have the $sign. So when I say workers, you can see once I put the $sign, all the columns in your data frame is going to be what's shown. So you can even use your mouse to click it or you just type it. Once you just put the $sign in front of a variable, and that variable is already stored in your R environment, then all that columns is going to be outputted. Let me show you for that of the empty class. So you can see $sign for empty class. You can see all the columns we have in empty class. MPG, CYL, DISP, HP, DRAT. You can see all the columns we have. So this is just, it's even more easier than even using the square and the double square bracket. That's why I say most of the times when you're working data frame, is in fact when you even see other people code, you'll be seeing what the $sign is usually used to access a column. So now once you just put the $sign, you can either use your mouse to click the column you want to use, or you can just use your keyboard to just type it. You can see it now. You now have the vectors of that particular column. So now for my workers, now I can just say married. I can see what I have a vector of it. You can see I have the vector values of it. So the $sign also gives you what the vector values of it. It gives it to you in a vector. Okay, so now what if now? So Mr. Fika has mentioned something earlier on. That's why I say that she was close to it. That's if you want to add a column or a row to your data frame, you can also use the rbind and the cbind function. So I know all of us understand how that actually works. Is that not true? So just like a matrix now. So look at my workers now. I have my workers data set now. My workers, and now want to add a new row to it. So new row means I'm going to be using the rbind. So it's just like you have 2 ways. So the way I gave earlier on was when you're creating the data frame. But what if you already have a data frame, that is, you are not the one that actually created it? I don't know if you understand what I'm saying.
Yes, we understand.
Hello?
Yes, we understand. We understand.
Yes.
So in that situation now, I was the one that created that data frame. That was why we use that method. But what in the situation where another one that created the data frame? They actually gave it to you, just imported it into your R. But you now find out that you need to add a particular row or you need to add a particular column. So this is where the rbind and the cbind function now comes. So now we're going to be using the add bind. I want to add what? A new row to my what? Data frame. So I'm going to say add bind. Then first of all, I'll be giving my data sets. So I need to allow that function to recognize my data frame. So I'm going to be giving it, then I'll now give a vector of the row I want to add. So you can see it's Johnson. So 49 and false. Okay. Okay, so it's actually 4 columns, sorry. False, then 5. Okay, so you can see it now. So now I know you've asked a question that, okay, why are we now giving a vector of different data types? So the thing now is that it is actually assigning each of these values to their respective columns. So, and once they go into their respective columns, they assume the data type of of their respective column. So now once 49 goes here, it's going to be assumed as a numeric. Once false goes here, a Boolean value, number of children also is going to be numeric. So it's not as if we're actually creating a full vector from this particular vector we give now. So we're just allowing this function addbind to assign each of these values to their respective columns. So now you can see how we have already added a row to this our data frame which we created called workers. So what if I now to create a new data set from it? So I just go back and now create a new workers data. So new workers data. Now this is now a new data set. So if I call new workers data now, you can see it, I have my data set. So now the same thing also applies with the cbind. So the cbind is going to be for column. I now want to add a column now. So that column now I'm going to be calling it, I'm just going to be calling it, let's say, diabetes. So if the person is diabetes, I will assign it to 1. If the person is not diabetes, I will assign it 0. So that means how many values should we be expecting the vector will be creating inside the function? How many values should we be expecting?
6.
So I'm going to be expecting 6, right? So now I'm going to use the cbind function. I will now you give workers. Then I will now say what? Children. So remember, it's a column, so we have to give the name. You can see it's children. Sorry, I say children. Let's just say diabetes. So if the person is actually diabetic, is equals to, they will now start giving our vector 1, 1, 0, 1, 0. So okay, 6, right? And 0. Okay. Cbind workers datasets. Okay, I think how many rows you have here? 6. Okay, name is the new workers. This is the workers I'm using. So new workers data. Okay, so now you can see we use the new workers data. So the new workers data is the one with the 6 rows. So you can see it has already created or added a new row to my new workers data. And now I have a column of what? Diabetes. You can see 1, 1, 0, 1, 0, 0. So these are, you can also use the cbind in terms of data frames. So the cbind is in matrices, you can also use it in what? Data frames. So now if you want to now remove a row now, let's say in these are new workers. So new workers data. I now want to remove the 3rd row. So I'm going to use the -3, and I want to remove the 2nd column. So -2. You can see what I'm having now. So 2nd column has been removed, which is age, and what? 3rd row has also been removed, which is, you can see, which is Rebecca. So the details of Rebecca has also been removed. So this negative indexing, we talked about this yesterday. You can also apply it also in data frames in terms of removal and adding of what, or in terms of removal of rows, and in terms of removal of rows. You can also combine 2 data frames together with the cbind function. So now we have a workers data set now. So let me just combine the workers and the workers data set together. So the cbind is actually a powerful function now. I have a data frame 1, which is workers. I also have another one, which is what? Workers. When I combine it together, it is because this space is a little bit, let me expand it so that you can see it. So you can see it now. Cbind, workers and workers are being combined together. You can see we have workers here, and we also have what? So it's like joining what? 2 of them together. So if you have 2 data frames and you want to combine them together by their columns, you use the what? The cbind function. So what if we have by their rows, we can also use the R bind. So let's just say we have this workers. So you can see it now also by the rows. So if you have two data sets together and they're having the same columns. So instead of just having various data sets as various variables, you just combine all of them together with the workers, and you have a single data frame. And can even create a new variable from this particular created data frame. So these are the data structures which we have in R. Vector, the list, the matrix, the arrays, and also the data frames. Okay, so a quick question before continuing now. Can the vectors data frame contain multiple values, multiple data types or not?
Can the vector of what?
Can the vector data structure contain multiple data types inside a single variable or not?
No, it requires any other data type to the preferable data type, something like that. So if you have like a character and a number, it will pass it to character. If you have like a number and boolean, it will convert it to a number.
That's good. Okay. So Mr. Fikat, this one is for you. Okay. Which function do we use in creating a list?
To create a list.
Yes, which function do we use?
Is list.
Okay. Can we have a list inside a list inside a list? Is it possible?
Yes.
Okay, that's good. So what if you want to index that particular an element in the list? What do we use?
If we want to index, we'll call the list name, then we'll use this double, what's the
square bracket?
Yes, double square brackets, then yeah.
That's good. Okay, that's good. Okay. So now, how many dimensions does an array has?
Array, more than 2.
3 dimensions.
How many precisely? The exact value. Okay. What of a matrix?
2.
2. Okay, that's good. Okay. So what do you want to check the dimension of both of them? Which function do I use?
Dimension, dim. DIM.
Yeah, that's good. Okay, now, so in a data frame now, in a particular column in a data frame now, can I have, let's say, for example, now, under these workers now, under this married now, can I be having true and also have the name of it? Can I be having true and have a number in this place? Is it possible?
No,
No.
Data frame.
Uniform data type.
So they have to be of the same data type, right?
Yes.
Okay, that's good. Okay. So now if I want to now, does the using the dollar sign now to access the columns in the data frame, can I use numbers?
No, it's just the variable name, the column name.
Okay, that's good. Okay, that's a good one. Okay, thank you very much. So now let's conduct our case study. Well, first of all, let me introduce you to what we call packages. So most of the time, some functions are not available in R. So because these functions are not available in R, so other people have already created packages to make life easier for you. So you don't need to reinvent the wheel or go and start afresh, be creating functions yourself or things like that. So we have a lot of packages in R, and by default, R even comes with also some packages which you can load to perform. We have packages for performance statistical analysis, and we have packages that are just data sets inside the packages. We also have visualization packages. So any work you are doing is just based on what someone have told you or what I've already read online. You now know, okay, these packages can actually work for a particular task I'm trying to do. So now in this particular case study we'll be conducting, we are going to be needing some packages, though the package we are going to be needing is the ggplot package. So I don't know if any of you heard of the ggplot package.
No, I haven't.
Have any of you heard of the ggplot package?
I've heard it.
It's a data visualization package. Is used for conducting data visualization. So if you want to install a package in R, because most of the times packages doesn't come in R, so you use the command install.packages, another function which I would like you to check out after the class. So install.packages ggplot2. That is the name of the function, the name of the package, sorry. So you have to be sure that the name of the package is correct, else you will not, it is not going to install it for you. So I already have it installed on my PC, but if I also run it now, it's going to just update it for me with the recent version. So let me just run it. Install.packages ggplot2. So you can see this is what you're going to be seeing. It's going to be installing the package for you into this. So you can see that it has already successfully unpacked it and is already installed inside my local machine. Then that's not all. It's only installed that into your PC, but you cannot start using it in R. So what if you now to start using the functions inside that particular package? This is when you now use the library. The library function is now going to load, or the library function allow you to load all the functions inside that particular package. So I'm going to use library ggplot2. You can see as I even type in, it's going to be listing all the packages which you have. So any package that is sharing like similar name to it, you're going to be seeing it till you reach the package which actually want to load. So when I now load the library ggplot2, and it shows me this, then it means it's already loaded. That means I can now use functions that are in this package. Mind you, any function you see in ggplot2, I'm not going to see it in another. I'm not going to see it in another package. It's only restricted to that particular package. So that's why we call it a package. It only contains function which we could not have in R. So we have a lot of packages with a lot of use cases. So that's why the documentation is very important, both the online, the offline documentation. You check for the functions, what a particular package, what it actually does, then what it does it. So now the data set we'll be working with is sales data sets for a motorcycle organization. So first of all, I'm going to be loading the data sets, importing it. And if you want to load a data set, so mind you now, let me check my folder. Okay, so you can see currently now my folder now. So this is the data set now, sales.csv. So because of the fact that my data sets and my current R script, or let me just say my markdown file, since I'm using a markdown file, they are in the same folder. Because let me show it to you now. You can see you can see my data set now, sales.csv. You can see it here, right?
Yes.
Then you can now see DA with r.qmd. Look at this file now currently. You can see both of them are all under the same folder, which is this R. They're all under the same folder. That is why if I want to load my data set, I will just be using the name sales.csv. But the situation where your sales.csv is inside a folder, for example, data. I have a folder called data and sales.csv inside folder. It's inside that particular folder. But my file where I'm writing my script is not under data folder. Now I'm now going to type the name of my folder, then sales.csv. That means please read sales.csv for me under the data folder. I don't know if that's clear. So now if you have sales.csv under a particular folder, this is how you just do it. You first of all call your folder name, just like you see it on in some slash. That means a particular file is under a particular folder, particular folder is under a particular folder. So this is how you are going to now allow R to access that file and import it for you. But currently now our file and the data are both sharing the same folder. So I'm just going to call it by the name directly. And the function we use to import a CSV file. A CSV file is comma separated value. So this is how a CSV file looks like. Let me open this. So this is how a CSV file looks like. You can see it is having commas. First of all, you have a column names. Can you see it? You will now start having the observation is saved with commas. You can actually open a CSV file also in Microsoft Excel. So a CSV file is usually saved with commas. That's why it's called comma separated values. So most of the times you can save your file in Excel as CSV file, then you now import it into but most of the times in the default file format in Excel, usually an Excel workbook. Because in a CSV file, you cannot have more than one Excel sheet. You can only have a single Excel sheet in a CSV. You want to save a particular Excel file as a CSV file. So now the read.csv function is what you use to read the CSV file. This read.csv cannot work on any other file except a CSV. So that's why it's called a what? That's why it's not just a read function, it's a read.csv function. So now when I now run this now, you can now see that my data sets says, let me clear this. So let me run this again. You can see I now have my data set called says 1000 observation of 8 variables. If you now want to view your data set, instead of using that view sales function, you can just click here also. Can you see it? Just click on this place and it's going to open it on a new tab. So can you see the data sets now that we're having? This is the details of transactions that are made in a particular organization that deals with motorcycle parts. We have, I think this should be 8 columns. We have 8 columns or 8 variables. And you can see this is what the date the transaction was made, the warehouse the transaction was made from. We have the client's type of that part of a transaction. That's which clients performed the transaction. Was it a retailer or a wholesaler? We also have the product line, where a particular product, which product line does it belongs to? And we have quantity, and also have what unit price. So we have the unit price of that particular item. We have the quantity that was bought, and we have the total, which is unit price times quantity. Then we have the payment system. Was it a credit card, a cash, or a transfer? So 3 payment system was actually used: credit card, cash, or transfer. So I'm going to be answering some questions based on this particular data set. I can see what I already explained earlier on also. Each column, different data, different kind of, the columns are carrying different type of data types, but within each column, they're all having what? Sharing the same data type. So now I've already imported our data now. I've already saved it as what CS, which you can see in your environment. Always take note that if you don't see your data in your environment, then it means you haven't loaded it. So what if I now want to export a data set? Imagine now I have a data set, or I've already done something now. Okay, let me just do it like this. My sales now, I want to use $sign, or okay, let me just use this single square bracket. And let me say 4. So you can see now I just subsetted only what product line. So now product line, I want it to be a data set on its own now. So how do I now export this? This is where I use the what write.csv function. So the write.csv function allows you to what export that's a data. So you've already have a data which already summarized, or you have already summarized a particular data. You want to now export it into your file and use the write.csv. So now, first of all, you give what? You have to create a variable. Like now, this particular data set I've created now, I'm going to call it a variable. I just call this subsets, and you say sys4. Then inside my write.csv, I'm now going to say subsets, then comma. So this is the name of the variable. Then what you'll be giving next now will now be the name of the file. So please take note, name of variable first, then name of the file, which is what subset.csv, then enter. So you can see now subset.csv has already been created now. So this is my what subset.csv. I can see the time it was created, 8:53 p.m. January 25th. And also see this side. So this means what? You use the write.csv function to what? Create a data set or export a data set. Why use the read.csv to what? Import a data set. So now let's analyze our data. We can use the head. So the head function allows you, like now, if I'm to call my whole sales data now, you can see it's going to be what? Loading everything. And it isn't going to be returning a warning that what maximum has already been reached. So to prevent something like that, now I just want to view, since you're only interested in your columns, you just want to be viewing the head of your data. So the head function allows you to view the top 5 rows. When I say head of sales now, I see, okay, let me expand this. When I say head of sales, this is serious. Let me just take it to the estimate. Okay. So you can see it now. The head of sales allows you to view. You can see it allows you to view the top 6 rows, allows you to view the top 6 rows of the data set. So by viewing the top 6 rows, you can now know the columns you are what dealing with without it reaching maximum number of rows or something like that. So now when I say head of sales, 5, you can see it's going to give me what? By default, it is what? 6. But by giving the number of values I want, that by giving a value, it gives me the number of rows I want. If I say head 1, head of sales, then 1, I see I have only what? 1. I see I'm having only what? 1 row. If I also say head of sales 20, I'm going to be having what? 20 rows. So this is how you can also what? Use the head function. It allows you to view what? The top rows of the top n rows of your data set. So the opposite of the head is now the tail. The tail allows you to view the bottom n rows of your data sets. So the same thing also with the tail, you can give your n value. If you want your n to be 10 or you want your n to be 5, you can give the value to give you the bottom n rows that you are interested in. So if you want to check the data structures now of your data type, you can use the str function of sales. You can see my data structures now. You can see what, first of all, it tells me that it's a data frame, 1000 observation of 8 variables, first of all. You can now see the dollar sign here, meaning this is a column. So this dollar sign here means that what, this is a column. Because the column is a what, character. You can see it stored it as a character. Then also the warehouse, you can see the warehouse, that is stored as a what, character. Client type is stored as a character, product line as a character, quantity as an integer. You can see it. Then unit price as a numeric, total as a numeric, and payment as a character. So you can see how you can get the various data types of your data frame. So this allows you to be able to know how you can now handle those particular data types. So what if I now run the summary function where I was talking about now? Summary function I was talking about earlier on. Summary of sales. You now see summary of sales here. So you can see that summary of sales now gives me what? The details of both character and numeric. But under the character, it's only giving me like the length. These are information which I don't actually need. So where I actually need information is based on the numeric values, the quantity, unit price, and total. Where you can now say I'm having the minimum value. I already explained this earlier on. Our first quartile, median, mean, third quartile, and also maximum value. So now the first question I want to be answered, I want to get the total sales that was made. So I want to know how much was actually made from this particular organization. So I can now use my sum function. So first of all, now I have a vector of what sales total. So what you should also note, if you know your column name, you can also use your column name inside the square brackets. Like now in this place, sales total, you can see it. You can use your column name inside your square brackets. So now I can now say sum of what? Sales total. This will now give me how much was made. You can see $289,113 was made from the organization. So this now you can now use a sum function on a particular column to now get what the total. If you apply it on a column which is not numeric, you are going to be getting an error. Something like if you're having something like a character column. So now what of the total payment that was now made by cash? So I want to get the total payment that was made by cash. So first of all now, that means I need to know what? I need to know payment that was made by cash. And after getting the payment that was made by cash, I'll now get the total of all those sales that was made under that. So first of all, that I'm going to do now. So we have what sales, what payments. So this is going to return the vectors of all payments that was made. Can you see it now? So what if I now run something like this? I say sales payments. And sales payments equals to, you remember our logical operation, comparison operation, sorry. So sales payment is what? Equals to what? Cash. You can now see what is going to be returned is going to be what? Is different from what I had earlier on. Earlier on, I just got the values of all the columns. But now I'm trying to check if each value is equals to cash. If it is equals to cash, true. If it's not equals to cash, false. So it's going to be going like that. And this number actually seen here is the what? Is the index number of the first value in that particular column. So you can see 1, 2, 3, 4, 5, 6, 7, 8. When you go here, you can see it is 9. So which means this takes the value of 9. This takes the value of 17. This takes the value of 25, and so on and so forth. So now it has now checked to see if each of those particular values is equals to cash or not. After that, how do I now filter inside that particular data set to get only observations or rows that are what? Cash. That is the payment was made by cash. So I'm now going to what? Inside my sales, inside my square brackets, I will now apply that particular filter, which is this. Go to copy it and paste it here. So try and remember this is for the rows, then comma, because I need all my columns, and I run it. So you can see it now. With the problem, let me use the view function. So I'm going to use the view. I'm going to put everything inside the view function so that we can see it on a new tab. So I just put all of them inside a view function. Then enter. When you now check this, now you can now see that what all these are what details of what cash. You can see it all true. They are all for what cash. So this is how you can what filter your data set. You first of all have to what know the column which you are interested in. They will now use an equality. For example, now we want to check if it's equals to cash, a comparison operator. If it's equals to cash, the same thing you can also do for a numeric, maybe less than equals to. You are trying to check total payment that was less than what 100. You just change it to what less than or equals to what 100. So after you now check that, it's now going to check each value to see if it's what satisfying that particular condition. Then you now carry the whole of it and put it inside your square bracket so that I'm going to filter all those values out. Then you'll be able to now what see your filtered data sets. So now, but now our question was actually to get what total payment that was now made by cash, which means we still have a work to do. So I'm going back to it now. So what I'm going to be doing now, I'm now going to access only the total for it, because if you look at this now, this is already a filtered data set. So to avoid confusion, let me just create this as cash payments by payments cash. Let me just call it payments cash. So you can see it now. I've already created what another data set. This is a filtered data set. Then I'll now say what payments cash. Then I can now use either my $sign or I can just use my square bracket of total, any of them. I now see I have all my values. So that is what for the payments cash. Then I'll now use the sum function to get all for me. Sum. So I can now see this is the total payment that was now made by what cash. So this is what we have. Another example now you can see here we have is what sales most expensive item by unit price. So now how do we now check this now? So we are going to say most expensive item now by unit price. We use the maximum function now. We have a function called maximum. So under the maximum, I now say sales, then what's total. You can see what this is my, okay, sorry, we're talking of unit price. I'm going to be using unit price. So this is my this is the maximum unit price, which means this is the most expensive item. So since I already know my maximum unit price, but I don't know that particular item, how do I now get the details of that particular item? I'll now filter for that particular item. You can see it here now. So what sales unit price strictly equals to 6.62. So this is going to get me the details of this particular item. So when I paste it in my console now and run it, you can see the item. So you can see the item now. And this is the details of this particular item. You can see the day the item was bought, the warehouse it was bought from, the client that bought this particular item, the product line it belongs to, the quantity, the unit price, the total, and also the payment method. So are we clear with that? Do we understand what's we have been doing now?
Yes.
Okay, that's good. So this is how you can now filter your data sets. You can try a lot of filtering. You can use this. You can see how important it is. Those comparison operators we treated earlier on. That was on day 2. Those comparison operators, you can see their importance here. You can also use the less than to use it to check particular. You can to filter observations that are actually less than a particular value. You can also see the square bracket that is also becoming more advanced and complex. And you can apply most of these operations into just a single line. So this one actually did earlier. I just break it down. That is for where I created a new variable called product payment cash. So you can actually just do it like this. So here is your filtered data set. After having your filtered data set, you now apply another square bracket. That is to get the total column. Then you now apply your sum function. But if you are starting out, you can just be breaking it down, and with time you can be combining it into just one single line of code. So now you can now see also another here, just similar to what we did now. Total sales made in each warehouse. If I run this now, we have the value of each warehouse. You can see it. So you can see it. So I'm just changing the warehouse name. This is just similar to what we just treated now. I'm just changing the warehouse name. So now we also have what we will call visualization. So it is very important. One of the most important things as a data analyst to visualize data. So as a data analyst, you are not visualizing, you find it hard for people to understand your insights because nobody wants to be reading reports or going through long documents, so things like that. So because it's a popular saying that a picture speaks 1,000 words. So just from your picture, people will be able to know that, okay, this is what you're actually trying to pass, and no matter how lay someone is, you'll be able to understand what the message actually you want to pass. So that was why we installed the ggplot2 package. And after installing the ggplot2 package, then we now loaded it because this is the visualization library I want to be using. It's one of the most popular, if not even the most popular packaging app, the ggplot2. So I don't even know why I've not even make it to just even come with the R itself, since most people usually use it a lot. So if you want to load the ggplot2, use the library ggplot2. So ggplot2 function is actually simple. It's a very simple function. So let me just expand this. I'm not going to be using the console now. I'm just going back to this place. So you just take this like my script editor. So just take this particular place like my script editor. So let me make it easy to understand. So unlike other functions, there's something peculiar with the ggplot function. Well, we'll come to that. So now let me create a new code chunk. Control I. So this is the ggplot2 function, is the ggplot. So this ggplot function actually takes two major arguments, data and mapping. So these are the two major arguments you take. Data, you give in your data, the data you want to analyze. Without any data, you are not getting any visualization. And your mapping, you give in the details of your mapping. So what and what your, which axis do you want to map? You have an x-axis inside that your data. If you are visualizing, you are not actually visualizing all your data. You are only interested in some specific columns or specific variables. Now, it is in this mapping argument you now give those values. Okay, my x-axis now is going to be this particular variable. My y-axis is going to be this particular variable. So this is what you now do in the mapping. Now, after now doing the mapping, what's now constant? So first of all, now let me give my data, which is sales. So I can just say data is equal to sales. I say that, or I can just give it all through as what sales. So it's going to be dirty like that any way you want. I just give it as the sales. The mapping now is not going to be equals to aesthetics. Then it is inside this. This is what by default. It is always what mapping is equal to aesthetics. In some people's code, they are just going to be seeing aesthetics as this. It's also the same thing. So mapping is equal to what aesthetics. Then now currently I want to visualize my warehouse by the total that was made in each warehouse. That's what I want to do now. So first of all, now I'm going to give my x-axis, which is warehouse, because now we are plotting a bar plot or a column plot, a warehouse. Then I'll now give y is equal to what? Total. How much was total amount that was made in each particular warehouse. Then, okay, let me just leave it like this. Then we'll run it. So you can see what we have now. We have a blank file. You can see it has already it has already designed my graph for it. So this is like it gave you a graph sheet. Okay, this is your graph sheet. This is what you want. But what you actually want, which is the bar plot or the column plot, we have now already done that. So now currently I only have an empty graph sheet where we have the total and we also have the warehouse, which on the x-axis. So you can see how you can relate this with the code that we just had now. You can see the mapping x equals to warehouse and y is equals to total. So how do I now add my data visualization? Speaking of addition, this way now is the addition sign. So you just use the addition sign to now add your data visualization. So we have every data visualization starts with geom. The geom, I think we say prefix. So it starts with the geom prefix. Then anything that follows after it is now the visualization. So you can see them, there are plenty. We have geom bar, we have geo column, we have a lot of them. It depends on kind of visualization which you want to do. So currently now we're interested in the geom column. I'm going to use geom column and we run this. So you can see it now what we now have. So we now have our graph. You can see central warehouse, northern warehouse, I can see western warehouse. So central warehouse have the highest total transactions, followed by northern, followed by the western. So it's just as simple as this using the ggplot. It's a very easy package and easy function to use. You don't even need to put any argument inside your geom column. And most of the time, you can also put this argument inside the geom column. But just people have their way of writing it. Some people actually put it inside here, most of this mapping, and others leave it inside the ggplot function. But these are usually right mine. I usually leave all of them inside the ggplot function and leave the geom column or the data visualization function empty. So now this, you can see now the graph is actually looking dull. So what if you now want to add what colors to it? So you go to your aesthetics function, which is under the mapping arguments, and now put comma fill. So your fill now determines what the variable you want to color your graph with. So I'm going to be filling by warehouse, so which means color it by the warehouse. So when I run this now, you can see now I now have what colors on my graph. And you can see I also have a legend, which also describes what each particular color on my graph. So these are used the words, the fill arguments. So what if I now give field of another variable? Because we have payments. But I say field of payments now. You can see now I now have a stacked bar chart. You can now see that what each particular payment now is taking each a various color. You can see for cash, we have this particular color. I think this is pink. Then credit card, this is green. Then transfer, which is blue. You can now see the details of each under each particular warehouse. So these are the various manipulations which you can also use ggplot to ggplot functions to do. So now I've already answered the question. We are visualizing warehouses by their total transactions that was made. So now from this plot, we know that okay, central warehouse is the highest, the northern warehouse also have what's western warehouse. So now the next question also want to know is the total sales made by each client from the various warehouse. So how much is total sales from each client? You can see the same functions which we are having. When I also run this now, you can see now I'm having the various client types. So yeah, I made my field to be by the client type. So you can see retail and wholesale. So we know that what wholesale have the total have the highest total transaction, and this is because they actually purchase more items in bulk than retailers. Then the next question, okay, now, so geom column is not actually the only plot we have. So let's say now I want to plot, let me see. I want to plot a histogram. Okay, let me say I want to plot a box plot. So I want to plot a box plot. We have a visualization called a box plot. So a box plot actually takes a categorical variable on the x-axis and a numeric variable on the y-axis, just like a bar plot also. So you can just leave it like this and let's run enter. So you can see the box plot now we have. So the box plot is actually a complex plot. It also has its own interpretation. It's a very comprehensive plot. So one of the important things is the box plot that even from the sizes, you know that, okay, this guy is actually having a lot of, you can say a lot of observations are falling within these areas, and this line that I see here usually is to be the median value. So which means that what most wholesalers have the higher median price than that of retailers, and also fewer transactions were made under retailers, or fewer total transactions was made under retailers than that compared to that of wholesalers. So you can see now we just changed only this, as if from what column to what box plot. And also one thing you can also do on the bar plot is also orientation. In our geom column now that we did earlier on now, you can see this is a vertical bar plot. So what if I now convert it to an horizontal bar plot where you're having a lot of variables? For example, now let me change this client type now to product line. So when I run this now, okay, let me change the field also to product line. Okay, now, so you can see this now. So now we have some problems here now. First of all, you can see that the labels are overlapping each other. So this is not what something we want on our graph. So we want these labels to be clearly seen. So this is where we now need to create an horizontal bar plot. So horizontal bar plot means that what each particular value under a particular variable is going to be shown in an horizontal format. So we are now going to swap this axis. So product line, we call it Y. And total field, we call it X. And I run this. So you can now see I'm having a much more better graph now. So you can see I can now see my axis labels clearly. That is, so I've already made the y-axis to be my product line, which you are seeing it here now. And my x-axis now is now the total field. So this is how you can also change the orientation of a plot. You can do it for also other plots too that you are going to be using. You can also just swap, once you just swap their axis, it's going to change your plot orientation for you. And if we don't also do that, we also have some functions called. Okay, any problem?
Yeah, what if you want to sort the values? Like they should not be like descending the bars.
Okay, what to say that's where you now use the reorder function. We have a function called reorder, but the reorder belongs to another package. That's why I don't want to treat it now because we're going to follow a lot of things for the reorder function. Use the reorder function. Once you use the reorder function is not that the ggplot2 package. It's under another package called dplyr. So once you use the reorder function now, it's not going to reorder it for you. You're not going to see your graph in descending order. That's a good point you made because most of the times you don't want to leave your graph like this. So you want it easy for your viewers that are going to be viewing the graph to see it either in ascending order or in descending order. So we'll be having this, then followed by another one smaller than it, then also another. So the function that usually used to be used is the reorder. So I think as an assignment, yeah, you can check more on the reorder function and also exploit. Since you're already now, you can check the documentation, also you can use it. Most of the times, you use your reorder function inside your axis. Then that reorder function allows you to now to reorder it a particular value. Then it will now show you your values in either ascending order or descending order of the values. I don't know if that's clear.
It's okay. It's okay.
Okay. Okay. So that is it for this particular. Okay, we also have this, just the same now. We're also seeing for the payment system. So this is also for the payment system. You can see that most clients were paid by transfer. If you now want to see clients that are paid by transfer, under each payment system, I want to see the client type. You can just change this to client type. Okay. Just happening. Field is equals to client type. Okay. So why we're having this is because most of the wholesalers, actually, in fact, all of the wholesalers use transfer. That's why you see we're having this kind of funny black and bar plots. So all the wholesalers actually paid by transfer, while the retailers only paid by what, cash and credit card. This is understandable because wholesalers buy in bulk, so they can't be carrying cash about or even using credit card to pay. So all of them use what, transfer. Why for retailers, because they don't buy much, they use cash and they also use what, credit card. So that's why you can see even a graph. So you can see an information as complex as this is already passed in a single bar plot. So this is how you can use the ggplot2 package and also use the functions in the ggplot2 package. So this plus sign allows you to be able to add more items. That's why they say the ggplot2 works on the principle of the layer of graphics. So you add what's more layers to graphics with the plus sign. So your ggplot2 can even be as long as having 10 lines of code. That's you're adding more layers, adding more layers, adding more layers. We have a function that covers changing of legend. You cannot be changing your legend. You cannot be leaving your legend as client type. We also have other functions that allow you to also customize your team. If you want it to be a darker team, we have functions that does that. So we are going to be drawing the curtain here for the data analysis with R program. I hope all of us actually enjoyed the 3 days of the program, and we'll also be looking forward to your feedback. And if you have any challenges, you can contact us through our mail. I don't know if I've given my mail. You can contact us also through our mail. So also I'll be having our paid class, which is going to be coming up by March. You can check our site to see more details on that. Check our organizational sites. You can see more details on the paid class, which is going to be coming up on March. So I'm going to be stopping here. I don't know if we have any questions.
Don't you give scholarship for your classes, for your paid class?
Okay, we're working on that. We're working on that. Yeah, we're working on that. So if we make it open, then don't worry. We have your emails. We'll send it to you.
We can write later requesting for scholarship.
But we really appreciate your feedback. We really appreciate your feedback on just this program.
But you are doing
I really appreciate your feedback.
There's no doubt you are doing a good job.
Thank you. Thank you very much. I really appreciate it. Thank you very much.
Thank you.
And we are able to learn one or two things. Even though Mr. Aladi did major already has some hands-on experience already, I know this was like a refresher for him. So, and also Mr. Fitat, I hope the class was smooth, no challenges.
No, sorry, nothing for now.
Okay, that's good. Thank you very much. So please, in case you have any challenges, you can just reach me through my mail. You can reach me through my mail, or can even reach any of the instructors too. Also, you can also check the videos again on. You can check it on YouTube, and also our second cohort for other programs like Python and Power BI is also going to be coming up on February. What's with it? You can also follow through our programs. You can also.
Are you the instructor for Python?
See?
Are you the instructor for Python?
Yeah. I'll also be among the instructors for Python, either the morning or the evening class. So I can take any of the classes. So you can register for any of them. Maybe the morning or the evening class. We'll actually send you the link of the details. Then you can now register for it. We'll send you a link of the details.
Through our mail, right?
Yeah, through your mail.
So how do we now connect with you?
Okay. Let me just give my details on the chat. So let me give my mail. So this is my mail now.
Okay.
And also let me just give my, so this is my WhatsApp number. So any of them, you can just feel free to contact me.
It's okay. Thank you so much.
So I hope you are able to learn a lot. I really appreciate your presence here. And thank you very much also
Thank you.
for being with me. Okay. So, Mr. Aladimiji, it was nice meeting you. And also, Mrs. Tofika, though, sorry if we not made any formal introduction we started. I would have wanted to know your profession, where you're coming from, well, let's say where you're actually calling from.
The boss
Things
of
like
the
that. Okay. So this is actually coming up late. So where are you actually calling from?
From Lagos.
Wow. Lagosians. Okay, that's good. Okay, profession, please.
I'm a data analyst.
Wow, that's good. Oh, I like that.
Think
That's
data analyst.
good. That's good. That's a good one. Okay, thank you. It was nice meeting you. It's my pleasure meeting all of you. It was my pleasure listening to you. And thank you very much for attending the classes. Though my colleagues
Thank
were
you
not
for
available
taking
today.
us.
My colleagues are not available today. I don't know if they have any anything they wanted to add. So, but we also look forward to seeing you maybe in our paid class, also in our next cohort, which is going to be coming in February. So thank you very much for attending the classes. We really appreciate it. Appreciate your presence. So this is going to be a bye-bye for me. Okay.
Thanks. Bye.
Bye.
Yeah, bye.